Welcome everyone to this video tutorial on data mining. In today's class we will discuss about density based clustering methods. Fine. So to discover clusters with arbitrary shape, density based clustering methods have been developed. These typically regard cluster as dense region of objects in the data space that are separated by regions of low density. So DBSCAN is a example of density based clustering algorithm which grows clusters according to a density based connectivity analysis. Fine. So this particular algorithm grows regions with sufficiently high density into clusters and discovers clusters of arbitrary shape in spatial databases with noise. It defines a cluster as a maximal set of density connected points. Okay. So the basic idea of density based clustering involve a number of new definitions, so we have to look for this. Okay, so in DBSCAN, as you can see in this diagram, these are the regions of different density, but if you look at carefully at the dark blue points, these are indicate noise. So if you remember K-mean clustering algorithm, the K-mean clustering algorithm does not work well if there are noise. But what is the advantage of DBMS is that these are resistance to noise, because in the process of clustering the data points, it can identify the noise and it can eliminate the noise. Okay, and the another advantage is that DBSCAN cluster can handle clusters of different sizes and shapes. Okay, so as you can see here, these are the different density. These are the clusters with high density points which are separated by lower density points. So it defines clusters according to the definition of density. Okay, so what the DBSCAN algorithm do is that it takes two input parameter from the user. One is the density at a point P is defined as the number of points within a circle of radius epsilon. So this epsilon, it has to be given by the user. So we will look what is an epsilon, and a circle of radius epsilon that contains at least minimum number of points. So this epsilon and mean points, these are the two parameters which have to be supplied by the user. As we see in the example of K-means, the value of K is given by the user. In case of DBSCAN, mean points and epsilon are the two parameters which should be given by the user. Fine. So now we will look the definition by which we can construct the DBSCAN algorithm. In DBSCAN algorithm, the density is defined as the number of points within a specified radius. So density is the number of points within a specified radius. And what we can see, so if this is a point and if this is the radius, okay, then we can draw a circle. So this is the epsilon neighborhood of the point is. Why? Because by taking this much of radius we can draw a circle, and this is known as the epsilon neighborhood of the point, that is marked as blue. Okay, so the neighborhood within a radius of epsilon, so the radius is here epsilon of a given object. This particular object is called the epsilon neighborhood of that particular object. So this will be the epsilon neighborhood of this particular object, and this will be the epsilon neighborhood of this particular object. Okay, so this is the epsilon neighborhood, and you can see the density is the number of points within a specified radius. So if I have to say what is the density here, how many points are there? 1, 2, 3, 4. So the density is 4 within this particular neighborhood. The density is 4. Within this particular neighborhood also density is 4, and within this particular neighborhood also density is 4. And this is the epsilon which has to be given by the user. Okay, so this is the epsilon neighborhood of the particular object. Now see, if the epsilon neighborhood of an object contains at least minimum number of points, that is a mean points of the objects, then the object is called a core point. So as you can see in this particular example, mean point is given as 3. So the user has given that the value of the mean point should be 3. So what is the definition? It tells you that if the epsilon neighborhood of a particular object contains at least the minimum number of points, so at least 3 points, then this particular object is known as the core object. Okay, as you can see, if you draw a circle with the epsilon radius, this will be the epsilon neighborhood, and it contains 4 number of points which is greater than 3, so this will be called an core point. Or if you can see, if this is the object, then this will be the epsilon neighborhood, and it, since it contains more than 3 objects, so it is a core point. As you can see here also, it is, so these are the 3 core points. So core point is the another important concept in case of DBSCAN algorithm. A point is a core point if it has at least a specified number of points within the epsilon neighborhood of the object. Okay, next we will see what is a border point. A border point is a not a core point, but it is in the epsilon neighborhood of a point. Okay, now you can see, if you consider this point, okay, if you consider this point, this is within the epsilon neighborhood of this particular point. But if you consider this and if you draw a circle here, so it will not contain more than 3 objects, so it will not a core point. So the point which is within the neighborhood of an particular object, epsilon neighborhood of a particular object, but which are not core point, is regarded as the border point. Okay, so these are the border points. Why these are border point? But if you draw a circle of epsilon radius here, you won't get more than 3 number of points. That's why it is a border point, but it is within the epsilon neighborhood of any particular object. So these are the known as the border points. So we can see that border points are not core points, okay, but it is within the epsilon neighborhood of the object. There are another definition of another points which is known as the noise point. So how can you define a noise point? A noise or an outlier is neither a border point nor a core point. Now you can see these are points. These are not within the epsilon neighborhood. Okay. So these are which are the points or not. These are the border points. These are neither core points or border points. Then we call that particular points as the noise points. Okay. So we can see core points are within the epsilon neighborhood of a particular point, and it is containing more than minimum number of points. Border points are not core points, but it is within the epsilon neighborhood of some other objects, and noise point are neither core point nor border points. Fine. So these are the 3 different definitions of border point, core point, and noise point. This is another example of core, border, and noise points. Here you can see the epsilon value is 1, that is the radius value is 1 here, which is given by the user, and minimum number of point is 4, which is given by the user. Now you can see, so if this is a point, then if I take a circle, this is containing more than 4 number of points, 1, 2, 3, 4, 5, 6. So this will be a core point. Okay, but if you consider this particular point, so if I draw a circle here, so it won't contain more than 4 number of points, but this is a border point. Why? Because it is within the epsilon neighborhood of some other points. Okay, so this is a border point. And noise points are different as those points which are neither border point or nor core point. So these are the noise points. These particular noise points do not belong to the close proximity of any other point, border point. Okay, so by this you can define these 3 different core, border, and noise points. So the rest of the other definition we will see in the next video. Thank you very much.